Electromagnetic fields are invisible areas of electricity or radiation that are produced by electricity. What is electricity? Electricity is the movement of electrons or currents through a wire. Now let's get into electric fields. An electric field is a vector field surrounding an electric charge that exerts force on other charges, attracting or repelling them. Electric fields are measured in volts per meter. As voltage increases, so does electric field strength. Voltage is pressure that pushes electrons through the wire. These are produced when a device is turned on and can be shielded by walls and objects. The next part of electromagnetic waves are magnetic fields. Magnetic fields result from current flow caused by electronics. Magnetic fields increase in strength as the current increases and experience a rapid decrease when farther away from the source. Magnetic fields are measured in microteslas and are only produced when current flow through them. For example, power lines allow currents to flow through and can pass through most materials like living things in buildings. When combined, they are called EMFs, which cause electromagnetic radiation. By using an electromagnetic spectrum, we are able to identify the range of wavelengths or frequencies over which electromagnetic radiation extends. The two main EMFs are, first, higher frequency EMFs such as X-rays and gamma rays. They are ionizing radiation of the electromagnetic spectrum, causing direct damage to cells and DNA. Next is the low to mid-frequency EMFs like static fields and magnetic fields, which are presented in power lines, appliances, radio waves, microwaves, infrared, visible light, Earth's magnetic fields, and compasses. The non-ionizing radiation part of the spectrum is not known to damage DNA cells directly. When connecting non-ionizing electromagnetic waves and cancer, those studies were done, no true results were found, and investigators claimed, although we did not find a positive association, the fact that we observed indication of an increased risk in the group with the most recent exposure deserves further investigation.
Non-ionizing EMFs are considered to be harmless. Cancer.gov posted this theory and had some different studies on their website proving the theory. And some of the experiments conducted, they have listed out. One of them being how children raised near power plants with dosage of 3 to 4 units of microtesla or higher showed no signs of cancer. Parents were using Wi-Fi and home appliances and whatnot before birth, test the effects on the child, seeing if it would have any, cancerous tumors or anything, or any problems in the future. Showed no consistent results. And so they're only speculations with non-ionizing EMFs causing cancer. And one speculation is how melatonin suppresses tumor development. While they do not directly damage cells and DNA, they can reduce levels of melatonin, which helps with suppressing tumor development.
PMFE therapy helps delay cancer due to suppressing the vascularization and inhibiting angiogenesis. It isn't very popular, but it is affordable and it is portable. It can be combined with other treatments and is safe to use. The best bet is to keep your distance away from and spend less time with them. Ionizing radiation has enough energy to cause damage through radon, X-ray, gammas, and just ultraviolet rays. Radon is a radioactive gas given off by rocks and soil, with radium forming when uranium and thorium break down. X-rays and other medical procedures like CT, PET have very small chances of cancer, but the usefulness outweighs the risk.
In this part of the video, I wanted to go over, the chemical structure of what electromagnetic waves are. And to start off with this, I wanted to just stay out. So if we have a positive charge, or we have a wire and a current through a wire, it's going to emit electric fields and out away from the charge. And let's say, so basically that. And whenever we have these charges and these electric waves coming out, they're moving. And something that James Clerk Maxwell found out was that whenever an electric wave is moving, it creates a magnetic wave. And whenever a magnetic wave is moving, it creates an electric wave. And so if we have an oscillating wire, it's going to have a changing magnetic wave, which is going to create an electric wave. And when we have a changing electric wave, it's going to do the same. It's going to create a magnetic wave. And when this happens, we have something that looks like this, which is what an electromagnetic wave looks like. So we have the magnetic wave, which is up and down, and it's oscillating. and we have the electric wave, which is also oscillating, but at a 90 degrees of the magnetic wave. And this is going forward and backwards. And all of this is going in one direction here. And so we have this, and we have non-ionizing and ionizing waves, electromagnetic waves. And we have visible light, which is also non-ionizing electromagnetic waves. And all of these have obviously different wavelengths. And when it comes to different wavelengths, we use this formula here, which is basically the speed of light, which is 3 times 10 to the 8th meters per second. We have obviously the wavelength in nanometers, mostly. It's mostly used in nanometers. And frequency in hertz. And so why these are non-ionizing compared to ionizing is because the wavelengths are so big that the frequency is a lot weaker. So if, for example, if wavelength goes down, frequency goes up, and that's for ionizing. But if we go back to non-ionizing, the photons, which are basically just quantized energy, it's just quantity of energy. And the thing about these electromagnetic waves is they can only have, let's say, 1 photon. They can't have half of a photon. It's either one, it's just all or nothing when it comes to photons. So the equation for photons, which is the energy of a photon, is Planck's constant times frequency. So when we have a bigger frequency, we have more energy in these photons. And that's why these are non-ionizing, these are non-ionizing. Because whenever there's a higher frequency, there's going to be more energy in these photons. And that's going to start to do damage to us, or cause tumors and brain tumors and stuff like that. And you know, that's pretty much the gist of it. As we can see, you know, obviously smaller wavelength is going to be higher frequency because they are, you know, if one goes down, one has to go up. And whenever there's enough energy for these photons, which is in this range, the gamma rays, X-rays, and UV, they're going to be able to ionize our cells in our body and create these problems like cancer and tumors. As for the non-ionizing, like our cell phones, our Wi-Fi, radio waves, all of that, they're not going to have enough energy for their photons to do that damage to our cells. And that's pretty much it. That's what I want to go over. So, thank you. Okay, so on this part of the video, I want to talk about the reaction information about MEFs, and most importantly, ionizing MEFs. So, whenever we have these high energy photons, due to the high frequency of ionizing MEFs, like so low wavelengths, they cause ionization. They come down onto our cells and they affect them because of their high energy. The high energy affects our cell. So they cause ionization, which is just making something negative or positive, taking away an electron and causing that. So lone pairs, for example, are very susceptible to this. And whenever these MEFs, these high photon MEFs come in and interact with these, they will shoot off an electron. And now we have a radical due to these X-rays and gamma rays. And when we have radicals, they're obviously not the same as our regular molecule. And these radicals make a lot more of them. And so we can see examples of these here. And why these are important is because they create these mess-ups in cell DNA. So we've got a single-strand break, we've got a double-strand break, and we've got base mutations. And you can see how they're affected, like examples. So they'll break here, they'll completely break, or they'll affect the actual DNA, these here. So, yeah, and it doesn't, the high wavelength ones, like cell phones and Wi-Fi, they don't have strong enough energy in their photons to do brain tumors and cancer, and just cancer everywhere, and tumors everywhere. Whenever this happens, whenever these radicals affect very specific parts of the DNA, like these, it throws off the sequence, and it can change the production of protons. You can mutate protons or proteins, and proteins, and cause like cells to over-replicate, or not like stop replicating, and this is the cause of tumors and stuff. And so that's just an overall review on how the MEFs actually react, the ionizing MEFs react and cause brain tumors.